these are the notes for the last part of Chapter 8, 8.6, which is about solving systems of nonlinear equations in two variables. So remember that we did systems of linear equations, where we had, something x plus something y plus something z equals a number, and then another one of those equations, and we were trying to solve for x, y, z. Well, we could also do the same thing with nonlinear equations, like things that have x squareds or x to the thirds or other kinds of functions in them. They're still systems of equations, they're just nonlinear. And since they're nonlinear, we can't use our stuff we learned about matrices on them. Instead, we have to solve them with our other methods. We can either do substitution or elimination, just like we did in section 8.1. So it's just it's the same kind of concept, just different types of equations. So let's look at an example here. Example 1 asks us to solve this system by the substitution method. X squared equals 2y plus 10, and 3x minus y equals 9. So what I'm going to do is I'm going to solve one of these equations for a variable and then plug it into the other equation. I'm actually going to solve this bottom one because it's actually easier to solve. I'm going to solve it for y. So I'm going to move the y over and say 3x equals y plus 9. And then I'll move the 9 over and say 3x minus 9 equals y. Once I have that, I'm going to take that, and I'm going to substitute it in for the y right here in this other equation. And I'll do the work over here. So x squared equals 2, and then instead of y, I'm going to write 3x minus 9, and then plus 10. Distribute the 2 into the parentheses, so we end up with x squared equals 6x minus 18 plus 10. Combine like terms, so we have x squared equals 6x minus 8. Now because we have x squareds and x's, we would want to make this equation equal 0 so that we can either factor or use the quadratic formula. So I'm going to take this 6x and this negative 8, and I'm going to move them both over to the other side of the equation. So I'll have x squared minus 6x plus 8 equals 0. And then I can solve that equation. This one does factor. So we have x and x. To make 8, we can have 1 and 8 or 2 and 4. To make it be a negative 6, we're going to have 2 and 4, and both of them are going to have to be negative. And then we can set those factors equal to 0. And we get x equals 2 and x equals 4. So that means we actually have two potential solutions. Now that we have the x's, we can find the y's by plugging back into this equation. So when the x is 2, if we plug in for our y would equal 3 times 2 minus 9, which is 6 minus 9, which is negative 3. So my answer is 2 comma negative 3. When x is equal to 4, we plug into this equation, we would have y equals 3 times 4 minus 9. 3 times 4 is 12, so we have 12 minus 9. 12 minus 9 is 3. So we get 4 comma 3. So these are two potential solutions. We do want to check them, make sure they actually work in our system. So let's start with 2, negative 3. So plug that in. On the right-hand side, I have 2 squared, which is 4. On the left-hand side, 2 times negative 3 plus 10, I get 4. So that side works fine. That equation is okay. Let's check 2, negative 3 in this equation. 3 times 2 minus negative 3, we get 9. That's what we're supposed to get. So that answer works fine in both equations. Let's check for 3. So for this first equation, on the left-hand side, we would have 4 squared, which is 16. On the right-hand side, we're going to have 2 times 3 plus 10. That's 16 as well. Those two match, so that first equation is okay. Check the second equation. 3 times 4 minus 3, we get 9. That's what we're supposed to get. So that second one works as well. So we end up with two different solutions to the system, both of which are valid. And that does happen quite a lot with these systems of equations that are nonlinear. A lot of times you end up with multiple solutions. Let's look at example 2. Example 2 asks us to solve by the substitution method. We have x minus y equals 3, and x minus 2 squared plus y plus 3 squared equals 4. So I'm going to take this top equation. I'm going to solve it for x. So I'll add the y across and say x equals y plus 3. Then I will take that and I will substitute it for the x here in this equation. So I will have y plus 3 minus 2 getting squared plus y plus 3 getting squared equals 4. Y plus 3 minus 2, that's really y plus 1 getting squared plus y plus 3 getting squared equals 4. Then we actually need to square these out. Please remember that y plus 1 squared means we have y plus 1 times y plus 1. So when we multiply it out, we'll get y squared plus 2y plus 1. Over here on the right-hand side, or not right-hand side, but on the right of this part, y plus 3 squared. Remember that's y plus 3 times y plus 3. So that'll give us y squared plus 6y plus 9, and that equals 4. Combine like terms, we have a y squared and a y squared, so we get 2y squared. I have 2y and 6y, so that gives me 8y. And I have 1 and 9, so that gives me 10 equals 4. Now, because there are y squareds and y's, we would want to set this equation equal to 0 so that we can solve. To do that, we need to move the 4 over. So we'll have 2y squared plus 8y, and then 10 minus 4 is 6 equals 0. Now, we could solve it from this point, but we can actually do something to make our lives a little bit easier. We can go through and divide everything by 2, and that'll make our lives a little bit simpler. So 2y squared divided by 2 gives me y squared, plus 8y divided by 2 gives me 4y, 6 divided by 2 gives me 3, and 0 divided by 2 gives me 0. Okay. Then we would want to factor or use the quadratic formula. I'm just going to factor. To make y squared, we need y times y. To make a 3, we need 1 times 3. And for it to be a positive 4 here in the middle, it has to be plus 1 and plus 3. Set those factors equal to 0. Move the 1 over, we get y equals negative 1. Move the 3 over, we get y equals negative 3. Once we have those, we can plug them back in here to this equation to find our x's. So when y is equal to negative 1, we would have x equals negative 1 plus 3, which is 2. So my solution would be 2 comma negative 1. For when the y is negative 3, we would have x equals negative 3 plus 3, which is 0. So our solution would be 0 comma negative 3. And again, we can check them really quick. So we'll start with the first one. If we plug it in on top, 2 minus a negative 1, that equals 3. So that one matches. We'll check the second equation. 2 minus 2 squared plus negative 1 plus 3 squared. We get 4. which is what we're supposed to get. So the first answer is definitely good. Check the other one. 0 minus -3. That gives us 3, so that's fine. Plug it in the bottom one. 0 minus 2 squared plus -3 plus 3 squared. We get 4, and that's what we're supposed to get. So that bottom one is good too. So in the system, we end up with 2 possible solutions. Both were valid, and that is perfectly okay. Now, we can also use the addition or elimination method to solve these systems, but you have to be a little bit more careful with these. When you're doing elimination, you need to make sure that the powers are the same, meaning like an x squared can only be canceled out by a negative x squared. You can't have an x squared and a negative x cancel out. They don't work. This has a power of 2, this does not, so they can't cancel each other. So you got to make sure things have the same power before you try to cancel them. So in our next 2 examples, we're going to actually look at trying to do some of these by the elimination method. So here in example 3, we are told to solve by the addition method, which is the elimination method. We have our system 4x squared plus y squared equals 13, and x squared plus y squared equals 10. I think what I'm going to do is I'm going to leave this top equation alone. 4x squared plus y squared equals 13. But for this bottom equation, I'm going to multiply through by a -1. So I'm just going to take it and multiply it by -1. So -1 times x squared is -x squared. -1 times y squared is -y squared. And -1 times 10 is -10. And then I'll add these together. So 4x squared plus -x squared, that gives us 3x squared. Y squared plus -y squared, those cancel out. And then 13 plus -10 gives us 3. So now we have an equation that just has one variable. We can divide both sides by 3, and so we get x squared equals 1. And then we can take the square root, and so we get x equals plus or minus 1. So we actually have 2 possibilities for x. X could be +1 or x could be -1. So let's check what happens when x is +1. We're going to take 1 and we're going to plug it into either of these original equations. I'm going to plug it into the bottom one because it's a little bit simpler. So 1 squared plus y squared equals 10. So 1 plus y squared equals 10. Move the 1 over, y squared equals 9. Take the square root, we get y equals plus or minus 3. So I actually get 2 different y values for this x. So when the x is 1, the y can be 3, or when the x is 1, the y can be -3. So I actually get 2 different points, 2 different solutions from this x. Then we still have to check the other x. The other x is x equals -1. Take that and plug it into your equation. You have -1 getting squared plus y squared equals 10. -1 squared is still +1 plus y squared equals 10. Move the 1 over, y squared equals 9. Take your square root, y equals plus or minus 3. So for this x, we also got 2 y's. So when x was -1, we got a +3y. And when x is -1, we got a -3y. So we actually end up with 4 different solutions to this system of equations. Now I'm not going to take the time to check all 4, but I will tell you that all 4 of them do work. So it's okay. Sometimes you have a lot of answers, especially when you have 2 equations that both have squares in them. It's going to give you a lot of answers. let's look at example 4. This one asks us to solve by the addition method. Y equals x squared plus 3, and x squared plus y squared equals 9. I'm going to move the x squared over, so this is going to be negative x squared plus y equals 3. And then on the bottom I have x squared plus y squared equals 9. And we're going to take those and just add them together. Negative x squared and positive x squared, those cancel out. Y plus y squared, these are two different things. This has a square on the bottom, this one on top does not. So since they don't have the same power, you really can't combine them together. So all you're really going to get is y squared plus y equals, on the right hand side you have 3 plus 9, so that's going to be 12. Now because you have y squareds and y's, you would want to move the 12 over and make this equation equal 0. So y squared plus y minus 12 equals 0. Then we can either factor or use the quadratic formula. I'm just going to factor, of course. To make y squared, I need y times y. To make 12, I could either do 1 times 12, or 3 times 4, or 2 times 6. Looking at the number in the middle, the best choice is going to be 3 times 4. And so that way, since it makes a positive 1, the 4 would be a positive, and the 3 would be a negative. And then we can set those factors equal to 0, and solve. And so we get y equals 3, and y equals negative 4. So those are our y values for our solution. Plug them back into either equation to solve for x. I'm just going to plug them into this top one. So for when y equals 3, we're going to have 3 equals x squared plus 9. So 3 equals, no, actually not 3 equals. We're going to move the 9 over. Wait, sorry, not 9. I'm being silly. That's a 3 right there. I apologize. So we have 3 equals x squared plus 3. So take the 3 and move it over. You get 0 equals x squared. Take your square root, you get x equals 0. So one solution is 0, 3. For when y equals negative 4, we plug it in there, we get negative 4 equals x squared plus 3. If you move the 3 over, you get negative 7 equals x squared. So if you take your square root, x would equal plus or minus the square root of negative 7. Because it's a negative, that's an imaginary, so this would really be plus or minus I square root of 7. So that would be an imaginary solution that would work. So you'd have, let's see, I square root of 7, comma negative 4, and negative I square root of 7, comma negative 4. Now, this one didn't specify to only solve for real numbers, so this would be a valid solution to the system. If they had said only solve for real numbers, then the only solution would be this one, 0, 3. Which kind of depends on what direction they give you. The very last thing we're going to do is we're going to do an application problem. Because many different problems that are geometric in nature can be modeled and solved using a system of nonlinear equations. We're going to use the same process for word problems that we've normally done in terms of reading the problem, trying to put it into words, writing equations, finding a variable, all that fun stuff. All the stuff we've been doing for word problems up until this point. So example 5 here says you have 36 yards of fencing to build the enclosure that is pictured below. Some of this fencing is used to build an internal divider, which you can see there in the picture. It's here in the middle. It says, if you'd like to enclose 54 square yards, what are the dimensions of the enclosure? So we want to enclose 54 square yards. This right here is area. You can tell it's area because it's square yards. Well, we actually have two different equations here. We have one equation that deals with area, and we have another equation that's going to deal with the fencing that we're doing. Now, if you don't remember, area of a rectangle is length times width. And in this problem, our length is x, and our width is y. Area equals x times y. Now, we know how big we want our area to be. We want our area to be 54 square yards. So 54 is going to equal x times y. So that's one equation. We have another equation that deals with fencing. Okay. Well, when we do our fencing, we have to fence all the way around this, and we also have to do this internal divider. Now, if this length out here is x, that means that this side over here is also x. And if this width here is y, it means that the width here is y, and it also means that the width of this internal divider is also y. So, when we do our fencing, how many x's do we have to build? We have to build one over here and one over here. So we have to build two x's. Plus, how many y's do we have to build? Well, we have one here, one in the middle. So we have 3 y's. Equals, how much fencing do we have? Well, it says we have 36 yards of fencing. So our fencing is 36. And so there is our other equation. So we have an equation for area, we have an equation for fencing. It gives us a system of equations that we can actually solve. So what I'm going to do is I'm actually going to take this equation and I'm going to solve it for y. So I'm going to divide both sides by x. So y equals 54 over x. And then I'm going to take that and I'm going to substitute it in over here. So we have 2x plus 3 times, and instead of y I have 54 over x equals 36. So I have 2x plus, I need to figure out what 3 times 54 is. So my calculator, 3 times 54 is 162 over x equals 36. Now, this equation has a fraction in it. I don't usually like fractions, so what I'm going to do is I'm going to go in and I'm going to multiply everything by x to get rid of the fraction. So I'm going to multiply this by x, multiply this by x, and I'll multiply this by x. So x times 2x gives me 2x squared, plus, here the x's cancel, so I just get 162, equals, over here, 36 times x is 36x. Now, because I do have x squared and x's, I want my equation to equal 0, so I can either factor or use the quadratic formula. I'm going to move the 36x over, so I'll end up with 2x squared minus 36x plus 162 equals 0. And then to make my life a little easier, I'm going to divide everything by 2, just to make things nicer. So 2x squared divided by 2 gives me x squared minus, see, 36 divided by 2, I think it's 18, but we'll verify. 36 divided by 2, yep, it's 18, so minus 18x plus, and then 162 divided by 2, that's 81, equals 0. So then we would want either factor that or use the quadratic formula. I'm going to factor it. So to make x squared, I need x times x. To make 81, let's see, it could be 1 and 81, or it could be 3 and 27, or it could be, can't be 6, it could be 9, it could be 9 and 9. Yep, it's going to be 9 and 9. So they could do negative 18 in the middle, that's going to be a 9, that's going to be a 9, and then both of those got to be negatives. It turns out they're both the same, so we could say x minus 9 equals 0. Move the 9 over, we get x equals 9. So there's one of our dimensions. We know that one of these dimensions, the longer one here, is 9. Now that we have that, we will take it and we will plug it back in up here to find y. So y equals 54 over 9. 54 divided by 9 is 6. So now we know the two dimensions. The longer dimension is 9 yards by our shorter dimension here is 6 yards. So it's a 9 yard by 6 yard enclosure here. And we can check that it works by actually plugging back into our equations. So here we have x, y have to equal 54. If I do 9 times 6, that does equal 54. For our fencing, we know that 2 times x plus 3 times y has to equal 36. So we can check it here. 2 times 9 plus 3 times 6, that does equal 36. So it does work. That is a good solution to that equation. And that wraps up 8.6. As always, if you have any questions, feel free to just shoot me an email.